In this video, let us revise non-metals in chemistry. So we're going to answer various questions from different years, that is ECZ questions. The first question that we are answering is this one, that is B9. Carbon is asymmetrical and exists in many forms of allotropes. What are allotropes? So that is the first question. So to answer this question, allotropes are just molecules. So you can say allotropes are molecules that consist of atoms of one element, but have different structures, and geometrical shapes. And in this case also you should take note that they have also different physical properties. So allotropes are just molecules that consist of atoms of one element but have different structural and geometrical shapes. So the second question, that is B, give two crystalline allotropes of carbon. So two allotropes of carbon, we have one which is graphite, then we have the second one which is diamond. So on this particular part I have another video that I did on non-metals. I think the video contains other questions on this particular part. You might want to check it out. I'll put the link in the description. Let us have a look at the second question that we are answering. So greenhouse gases pollute the air. Chlorofluorocarbons, CFCs, are greenhouse gases. The question is, name two other greenhouse gases found in the atmosphere. So what are other greenhouse gases found in the atmosphere? So one of them, you have carbon dioxide. Then we have also methane. So these are some of greenhouse gases. So please be able to also type in or contribute what you think are some of the greenhouse gases that we can talk of here. Then Roman numeral 2 of A, state the respective origin of each of the gases. So carbon dioxide, what it means that the one that we've given, let's say carbon dioxide, we give the origin. Where does it come from? What are the sources, in other words? Okay. So for carbon dioxide, it can come from combustion of fuels. You can talk of from industries, respiration, decomposition, and also burning of waste. So all those are sources. Okay, what about methane? So methane also comes from fossil fuels production. So let me say fossil fuels production. So the process of fossil fuel production produces methane also, but this is not only the process that or one of the source of methane. So you can look at other sources. Okay. Then B, describe how the presence of CFCs, that is chlorofluorocarbons, in the atmosphere or upper atmosphere increases the amount of ultraviolet radiation reaching the Earth's surface. Now, one thing that you should know, that these CFCs deplete the ozone layer. And of course, the ozone layer, you know, that is the umbrella that protects us from dangerous rays of light. So now, the question is, describe how the presence of CFCs in the upper atmosphere increases the amount of ultraviolet light reaching the Earth's surface. So here we can say it depletes or finishes the ozone layer, depletes the ozone layer, which prevents the which prevents ultraviolet radiation from reaching the Earth's surface. So because it depletes the ozone layer, that prevents the rays of light from or ultraviolet from reaching the Earth's surface, then which means ultraviolet radiation is freely reaching the Earth's surface if the ozone is depleted or destroyed. Okay, so that is how you can put this answer. But of course, let me know how you can also answer this question. So you have to participate as well in contributing the answers. We are learning a lot from the answers, or I'm learning a lot from the answers that you also contribute. Then the other question that we can look at is this one. So this one is on that is from section C. So one of the questions that came in section C this particular year, and as you can see, section C, you are required to answer only 2 questions out of the questions that are given. And this is C1. Clean, dry air contains about 79% by volume of nitrogen. The first question is, name the gas which makes up, or name the gases. So here, take note. Name the gases which makes up the 21% by volume of air. Now we know that 21% is oxygen, but here they are saying gases. And normally nitrogen here is quoted as 78, but here we're given 79. Now if you add 21 and 79, it is giving us 100%. So all other gases should be in 21%. So in this case, we are going to talk of oxygen and also carbon dioxide. Carbon dioxide form part of this 21%. You can talk of other gases. Okay, you know what is found in other gases. We have argon, helium, and all that. Then B, a sample of polluted air was found to contain both nitrogen dioxide and sulfur dioxide. State a major source of each pollutant. So what is the major source of each pollutant? So this one is just the same as the one that we looked at previously, but here we are given the pollutants. That is nitrogen dioxide. So nitrogen dioxide, what are the major sources? So for nitrogen dioxide, the major sources of nitrogen dioxide, also we can talk of car exhaust. Okay, combustion of fuels, in short. So combustion of fuels, okay, produces nitrogen dioxide. Then sulfur dioxide, you can talk of burning of fossil fuels. So sulfur dioxide, we can talk of burning of fossil fuels, and also extraction of metals, like in the extraction of zinc, the sulfur dioxide that is produced. So please, some of the answers I might not write them here because due to space, but I guess you've gotten that. Nitrogen dioxide, combustion of fossil fuels, then sulfur dioxide as well, combustion of fossil fuels, but also extraction of metals. Then now if you look at these two, that is 2 of B, describe a test which would be carried out to confirm the presence of sulfur dioxide. What is the test that could be carried out to confirm the presence of sulfur dioxide? So for this one, in terms of writing, you can simply say bubble the gas through acidified. So since you are saying describe the test which could be carried out to confirm the presence of sulfur dioxide in the polluted air, just say bubble the gas through acidified potassium manganate 7, okay, potassium manganate 7, that is permanganate 7. If the gas, or let me just say sulfur dioxide turns potassium permanganate okay, let me just write it, permanganate 7 to, let's say, from purple to colorless. Okay, so you bubble through the you bubble the gas through acidified potassium permanganate, that is 7. If the gas is pleasant or sulfur is pleasant, the potassium permanganate will turn from purple to colorless. So that is the identity, that is the test that would carry out to confirm the presence of sulfur dioxide in the polluted air. Okay, I hope you've gotten this. So now we are on to question C. Show clearly by chemical equation how this gas takes part in these reactions. Show clearly by, okay, I think we have the question that we've closed here. That is question C itself for 1. Respiration and rusting are chemical processes which involves one of the gas in air. Okay, respiration and rusting, so we have two processes here, are chemical processes which involve one of the gases in air. Show clearly by chemical equations on how these gas take part in each of the reactions. So what we are told here now, if you are to follow it well, we are told to write the equation of rusting and of course respiration. So 2 of the equations. So for rusting, let me start with respiration. So during respiration, the gas that is involved is oxygen. Okay, so one of the gases, so oxygen is the one that is involved in respiration. So to write the equation for respiration, you know that glucose react with, okay, so glucose plus oxygen. So let me just write direct the balanced equation. So glucose plus oxygen, what is produced is carbon dioxide, water and energy. So what is going to be produced is carbon dioxide plus 6 water molecules, then plus, you can add at the end, plus energy. So this is the equation that you needed. Then for rusting is 4 iron, so I'm writing the equation, the balanced one as well, plus 3 oxygen molecules plus 6 water molecules, and what you're going to produce is 4 iron hydroxide. Okay, so this is how rust is formed. So this is the equation that you need on rusting, and the other one that you need on respiration. So this is what you require to answer on this question. Then question 3, one method of preventing rusting is sacrificial protection. One method of preventing rust is sacrificial protection. Describe how this method of rust prevention could be used in a pipeline, in oil pipeline, and explain how it works. Explain how it works. Calcium oxide is important compound that is manufactured from limestone. The first question is, state the method by which calcium oxide is made from limestone. So what is the method by which calcium oxide is made from limestone? Now, if you know, calcium oxide is made from limestone, which is calcium carbonate, by decomposition, and that is by using heat. So that is the thermal decomposition. So it is by method of thermal decomposition. Write the balanced chemical equation for the reaction or for the formation of calcium oxide from limestone. Include state symbols. So, like I said, it's from calcium carbonate, which is solid. Now, it is decomposed, so heat is involved. Then now what is produced is calcium oxide, which is solid, plus carbon dioxide, which is a gas. So that is the equation. If you look at this, this is balanced, oxygen 3, oxygen 3, carbon 1, carbon 1, calcium 1, calcium 1. What is the common name for calcium oxide? What is the common name for calcium oxide? So the common name for calcium oxide is called quicklime. So quicklime is the common name. Okay, question C. During production of calcium oxide from limestone, a gas is evolved as a byproduct. Describe the chemical test for the gas. Now, for us to know the chemical test, we need to know the gas. And from where we are coming from, carbon dioxide is a gas that is produced. So in other words, we are writing the chemical test, so we are describing the chemical test for carbon dioxide. So describe the chemical test for carbon dioxide. So the chemical test for carbon dioxide is that it turns lime water muckish. Okay, so when the gas is bubbled through lime water, it turns lime water muckish. So you can start from there. When the gas is bubbled through lime water, it turns lime water muckish. Then question 2 of C. By what method is the gas corrected when prepared in the laboratory, and give a reason? So now, one of the characteristics of a gas, which is carbon dioxide, you need to know that it's denser than air, and therefore it is corrected by method of upward displacement of air. That is one of the method, upward displacement of air, because it is denser than air. So you can write that, upward displacement of air, because it is denser than air. Then of course the other one is the downward displacement of water. So downward displacement of water. And why is it collected by this method? So the reason why is collected by this method, that is downward displacement of water, it is because it is slightly soluble in water. It is slightly soluble in water. So upward displacement of air, did I say downward displacement of air? That is upward, please. So upward displacement of air, and also downward displacement of water. And this is because it is slightly soluble in water, and it is collected by upward displacement of air because it is denser than air. These two methods. Then state 2 uses of the gas. So what are the 2 uses of the gas? So carbon dioxide. So you can give any of the uses. So I prefer giving the artificial one. So it is used by plants during the process of photosynthesis. Also, it is used in baking. You can talk also, it is used in making carbonated drinks. All those are the uses of the gas, which is carbon dioxide. So please also be able to contribute on this one. Don't ask a question, what about if I write this? Just give your answer. Be confident in what you are contributing. Okay. So we can move to the other question. So this is C2 of that particular year. So calcium hydroxide. So we are going to find some of these questions just repeating. Okay, so some of these questions are repeating. So calcium hydroxide or slaked lime is an industrial alkaline. Explain the meaning of the term alkaline. So what is an alkaline? So an alkaline is a soluble base. Okay, it's a soluble base. Or you can say is a substance which dissolve which dissolve in water and produces hydroxide ion as the only negatively charged ion. I guess you've gotten that. Is a chemical substance that when dissolved in water produces a hydroxide ion as the only negatively charged ion, or you can simply say it's a soluble base. Explain how calcium hydroxide is produced starting with limestone. So how is calcium hydroxide produced starting with the limestone? These 3 marks. So the first step, since we are starting from limestone, which is calcium carbonate, so the first step is decomposition of calcium hydroxide, calcium carbonate to calcium oxide. So you can say the first step, calcium or limestone is decomposed to calcium oxide. Then calcium oxide is dissolved in water to produce calcium hydroxide. So that is how it is produced from limestone. So the first step is decomposition of lime or calcium carbonate. You can put calcium carbonate to calcium oxide. Then calcium oxide dissolved in water to form or to produce calcium hydroxide. So that is the whole process. Okay. Then B, give two large scale production or uses of calcium hydroxide. Now in this question we've not been told to indicate even the equation at all steps, at all point, but if it was the first part of decomposition, we write calcium carbonate decomposed to calcium oxide plus carbon dioxide. Then of course calcium oxide plus H2O, what is produced is calcium hydroxide. Then you balance the equation, but we are not told that. We are just told to describe the process. Give two large scale uses of calcium hydroxide. So calcium hydroxide, one of the use, it is used in treatment of acidic soil or neutralization of acidic soil by what? By farmers. So this process is used by farmers to neutralize or to control soil acid, to control soil pH. So you can just say treatment of acidic soil. Then also used in treatment of acidic industrial wastes. Okay, so there are quite a number of the uses of calcium hydroxide that we can look at. So as you watch this video, make sure that you also contribute some of the answers. Okay, then the last question, which is C. A weak solution of calcium hydroxide is called lime water, and it is used to test for carbon dioxide. What are the questions? Construct the chemical equation for the reaction, include state symbols. So here they are just telling you to write the equation for the testing of, the reaction that happens during the test for carbon dioxide. Okay, so what really happens? Okay, so for this one, you need to know that calcium, lime water is calcium hydroxide. So calcium hydroxide, written as this. Carbon dioxide is bubbled in this lime water, which is a gas. Then what is produced is calcium carbonate, okay, which forms the white precipitate. It's the one that appears white or milkish, which is solid, plus water, which is liquid. So this is the whole equation for the test of carbon dioxide, and it's supposed to be here, please. Okay, I don't know why I've written it here. So calcium hydroxide plus carbon dioxide, which is a gas. This is aqueous. Then of course calcium carbonate, which is solid, plus H2O. Okay. Then give the chemical name of the salt produced during the reaction. So the salt produced is this one, which is calcium carbonate. Okay, that is the chemical name. Describe what is observed during the reaction. The solution turned milkish. So this was the observation. The solution turned milkish, or when carbon dioxide was bubbled through calcium hydroxide, the solution turned milkish. Okay. Then now let us look at this question. Three gases A, B, and C have properties shown in the table. As you can see, there's gas AB, density, solubility in water, and appearance. So here is the diagram. Some apparatus used to correct gases are shown in the following diagrams. So we have X here, the gas inside gas. So this is X, this is Y, and this is Z. What are the question? Which apparatus X, Y, or Z is most suitable for to correct gas A? So what are the properties of gas A? So gas A is more denser than air. It is soluble in water and colorless. So if it is soluble in water, it cannot be collected with anything that has to do with water. So automatically cannot be corrected by Z. Now let us look at these other. Now for this one is when the gas is less denser than air, because normally the gas will go on top here and the air will be down here. But for this one is the one for gas that is more denser than air. The air will be on top, then the gas to be collected is at the bottom here. And now if you look at this is the method that we talked of, that one that can be used to collect carbon dioxide. Now, is carbon dioxide soluble in water? It is slightly soluble in water. Now, without even identifying all that, so which means this gas, it cannot be collected by this method, but we need the method that requires the gas that is denser. So which means can be collected by X. So this one can be collected by method X. Then what about B? So for gas B, what are the properties? Less dense than air. It is also soluble, colorless. So it cannot also be collected by what? By Z. So look at this. It is less dense than air. So can be collected by this method, which is Y. Gas C can be collected using apparatus Z. State why apparatus Z is more suitable than apparatus Y to collect gas C. Now what we said, so we are looking at why gas C can be collected by Z. Okay, Z is right here, which requires the displacement of water. And only gases that are slightly soluble, or that are not soluble in water can be collected by this method. So now, why is C collected? Look at this, it's insoluble in water. So, state why apparatus Z is more suitable than apparatus Y to collect gas C. Because gas C is insoluble in water. Okay. State why the apparatus Y is more suitable than apparatus Z to correct gas B. Now, why is it more suitable to collect gas B using apparatus? We've been told apparatus Y, of which we said that is the way it is collected. So B, apparatus Y. What is the reason? And this is because it's less denser than what? Less dense than air. So because gas, is it gas B, is less dense than air. And that is the reason why it is collected by that method. Okay? So that is it for this question. And of course, we come to the end of the lesson. So please don't forget to subscribe and also to share with others. Okay? As we revise, only some few days remaining for those that are writing internal ECZ. And at this moment, I wish you the best as you prepare. Make sure to check out my other videos, that is on non-metals. I hope you greatly benefit. So please, for those who are interested to join our online lessons for 2025, if you're preparing for 2025 IGCSE, Cambridge GCSE, and also ECZ exams, you can join us. We are open for registration. Lessons actually are already we've already started the lessons. So if you are interested to join us, you can contact the number 0976402563 to register. Otherwise, we can end here and see you in the next one.